Welcome to another video in the grade 7 to 9 GCSE Maths series brought to you by Strategy Maths. In this video, we're going to have a look at simplifying algebraic fractions. Before we attempt to do this one, let's have a look at reminding how we simplify a regular fraction, such as 8/12. We look for a highest common factor of the numerator and the denominator, which in this case is 4. 4 goes into 8 twice, and 4 goes into 12 3 times. Now let's consider writing the numerator and the denominator in factored form. So 8 becomes 4 lots of 2, and 12 becomes 4 lots of 3. In this factored form, we can see that we can cancel out the factor of 4 on the top with a factor of 4 underneath. So we end up with 2/3 as before. Now this factored form is the approach that we're going to take to simplify our algebraic fractions. We're going to factorise the numerator and the denominator and look to see if we've got any common factors on the top and the bottom which will cancel each other out. So let's begin to factorise our numerator, x squared plus x minus 6. We need to think of two numbers that multiply to make minus 6 and also have a sum of 1, because I've got 1x. Those two numbers are 3 and minus 2. So the numerator factorised is x plus 3 multiplied by x minus 2. Now let's take our denominator and factorise that. We need to think of two numbers that multiply to make 10, and those two numbers also have to have a sum of -7. The two numbers this time are -5 and -2. Two minuses multiplied to make +10, and -5 add -2 is -7. So on the denominator, we get x minus 5 multiplied by x minus 2. And we can see that we have a common factor on the top and the bottom, and the common factor is x minus 2. So we can simplify the x minus 2, and we're left with x plus 3 over x minus 5. Now this is our final answer. But I guess some of you might be asking, why can't we just cancel out the x's, since we've got an x on the top and an x on the bottom? Well, to answer that, you need to ask yourself, can we factorise further our numerator and our denominator? If we can't, and we can't get it into a factored form, like this numerical fraction, then we can't cancel out any common factors. And we can't simplify x plus 3 and x minus 5 because we can't factorise them. Let's take this one step further and consider substituting x with just a random numerical value. Let's go for 6. If I replace x with 6, 6 plus 3 on the top over 6 minus 5, that gives us 9 over 1, which is 9. Now imagine if I write that fraction out again and start cancelling out the 6's, because I see that I've got a 6 on the top and a 6 on the bottom. What I end up with then is 3 over minus 5, or minus 3/5, and we can see that's absolutely not the right answer. The answer should be 9. So hopefully that has illustrated to you why we can't just cancel out these x's in the same way that we can't cancel out these 6's. In order to cancel anything from the top with the bottom, it must be in factored form, and then we can cancel out any common factors. So x plus 3 over x minus 5 is our final answer. Okay, let's have a look at question number 2. Again, we're going to factorise the numerator, factorise the denominator, and see if we've got any common factors that we'll be able to cancel out. So let's have a look at the numerator. We need to think of two numbers that multiply to make 15. And they've also got to have a sum of -8. So those two numbers are -5 and -3. So the numerator can be written as x minus 5 multiplied by x minus 3. Now, if you haven't already seen my video on how to factorise quadratics when a is greater than 1, then please have a look at that one if you need a refresher on how to factorise this sort of quadratic. So for the denominator, first of all, we need to multiply a and c together, so the coefficient of x squared with the constant number, which is minus 30, two lots of minus 15. So this time we need to think of two numbers that multiply to make minus 30 and have a sum of minus 7. And those two numbers would be negative 10 and positive 3. Now that we've found the numbers minus 10 and 3, we're going to rewrite the denominator as 2x squared minus 10x plus 3x minus 15. And if you've seen my video on this technique, I use a reverse grid method to factorize this now. Inside the multiplication grid, I put 2x squared minus 10x, 3x, and minus 15. And then we factorize. The highest factor of 2x squared and minus 10x is 2x. We multiply 2x by x to get 2x squared, and we multiply 2x by minus 5 to get minus 10x. The highest factor of 3x and minus 15 is 3. Look how this works. 3 times x is 3x, and 3 times minus 5 is minus 15. So on the denominator, we have 2x and a positive 3 in one bracket. And in the other bracket, we have x minus 5. And we can see that on the numerator, we've got a factor of x minus 5. And on the denominator, we have a factor of x minus 5. So we can simplify those. So we get x minus 3 over 2x plus 3. We cannot factorize the numerator or the denominator, and therefore we know that we have got our final answer and it cannot be simplified anymore. So x minus 3 over 2x plus 3. So we come to our last question in the video. I chose this particular example because on the denominator, hopefully you can recognise this as being the difference of two squares. And they do like to put this in a lot of questions when it comes to simplifying fractions. And examiners report do note that this is a skill that students still need to, be better at, basically, and that's factorising the difference of two squares. So do make sure that you can recognise those. So to factorise the difference of two squares, we're going to square root 4x squared, which is 2x. And we're going to put that at the start of each bracket. And then we're going to square root 1, which is 1. And we need a change of sign, a plus 1 and a minus 1. Next, the numerator only requires one bracket to factorise it. It is not in the form ax squared plus bx plus c. It does not have the constant number. So we only need one bracket to factorise this with the omission of c. So we look for the highest factor of 6x squared and 3x, which is 3x. That goes outside the bracket, and we multiply 3x by 2x to get 6x squared, and we multiply it by 1 to get 3x. Now that it's in the factored form, we can see a common factor of 2x plus 1 on the numerator and the same on the denominator, so we can cancel those common factors. So we end up with 3x on the numerator over 2x minus 1 on the denominator. And again, we can't write the denominator in factored form, so we know that this is our final answer and we've simplified it as fully as possible.